Hey everyone, welcome back. This is Luis. This is video 3 on how I built an LLM powered content distribution system. So this is, we talked already overview on video 1, video 2. I went over the architecture and I mentioned that it was a layered architecture. So in this video, what we're going to do is a much deeper dive on what the heck is a layered architecture. So here we are in Obsidian. Big three things is this is an event driven architecture, which we delved into in the last video. Everything communicates through events. Events are typically a change in state, be that in S3 or in DynamoDB, that causes something to happen. It's a layered architecture. So this is all for separation of concerns. It helps orchestration, and it keeps my business logic separate from a lot of the rest of the architecture. It's not embedded into it. So it helps me have something that's very modular, very easy to upgrade different components without fear of breaking something else. Dependencies are fairly light. So I like the way that it works. Now, it is layered. So they say the dependencies are light. Depends which layer I'm on. If I'm on a foundational layer, it may cause me some issues, but I've architected it in such a way that even that should be easily mitigated. Lastly, it's service architecture. And I mentioned this in the last video. This all has to be self-managed. I'm moving away from Kajabi because of the high costs and really the overly limited that I am. I couldn't build this backend with it. So in a self-managed world, no server management is great. I don't have to worry about managing load balancers, everything auto scales, and it's pay per use. So I'm going to be paying a fraction of what I could be if I had any type of other platform. Trade-off is that I have to build it all and maintain it myself. But the beauty of something like this is that the work is in the front end. Once it's all working, it's working. All it's going to take is a couple tweaks here and there, and I don't have to worry about things breaking or calling support because I built it, so I know how to fix it, and it's all within my skill set. So you're going to notice that how I'm going to go through this is very different than the architecture that I talked about in the first or in the last video. In that last video, I was talking about platform layers and then actual functional elements of how things were layered together to include an orchestration layer. Here, we're going to look from a more technical aspect as to how those layers all interact. I mentioned how I have a admin UI that is running on Amplify. That's my presentation layer. Right? That is how I interact with the backend. I need to be able to interact with that backend in a way that doesn't have me pulling out the hair that I don't have. But with that, try to keep it as simple as possible. It's really limited just to giving me the data that's in DynamoDB, which is a lot of what's causing the events to happen that triggers lambdas and triggers actions throughout the system. So the next layer is the orchestration layer. This is EventBridge and DynamoDB. Now, S3 plays a role there, but the really heavy lifting is happening between DynamoDB streams and EventBridge. So everything goes through this. I want an orchestration layer because, as I mentioned in my last video, I want to be able to control all my rules and all my triggers in one place. And I don't want any business logic in there at all. Something happens, make this other thing happen. How does that other thing happen? That's business logic. That's something that I can code somewhere else. If I know that there's a change in state somewhere, something needs to happen. Okay. So that's what my orchestration layer helps me control. Now from there, like I said, something triggers. Now we go to business logic, which is running in lambdas. This is where we have my ingestion lambda, I upload something into S3 via Mountain Duck, which is what I have running on my computer here. That triggers an ingestion lambda because S3 tells EventBridge, hey, there's been a change in state. EventBridge then says, okay, that something was uploaded, so therefore I need to invoke the ingestion lambda, and that runs. Then after that's up and on a schedule, it'll go, hey, now it's time to generate content based off of what I just uploaded, and the logic on how that's done, again, living in a lambda. So everything else on how things actually get done is happening in the business logic layer with lambdas for each of the different functions that I have going on. After that, that lambda needs to interact with data. So there's a data layer, and the single source of truth for me, I made DynamoDB, right? I upload something in S3, the ingestion lambda then triggers, populates all that metadata onto DynamoDB. I manage everything through DynamoDB. Like I mentioned in the presentation layer, it's really just a UI for the DynamoDB. So everything is happening with DynamoDB though. That is my true data layer. S3, sure, that's data, but I consider that my storage, file storage. It's object storage, but storing files. And then configuration and secrets. That's also data that needs to kind of be maintained. Those are three separate stacks, if you remember that from my last video. But collectively, they form this data layer. And so everything that I need to manage, I know I need to manage within this layer. And lastly is that infrastructure layer, which I said, yep, I was calling my platform layer, but this is again from a technical aspect, is the declarative infrastructure, the type safe configuration, the reusable constructs. If you don't know what constructs are, we're going to get into that as we go through this whole architecture, but it's developing using constructs so that I'm not rebuilding the same thing over and over and over and over again. I use constructs in CDK so that I have a framework and a blueprint to build other components. So with that, get into architectural patterns. So with an event-driven architecture, components are communicating with each other with events instead of direct calls. They're not calling one another to do anything. This is S3 gets uploaded, something gets loaded up to S3, event bridge gets triggers a lambda. There's a change in DynamoDB, then there's a DynamoDB stream that gets sent to EventBridge. EventBridge then decides what lambda to run that. Again, now there's a schedule. If when on a scheduled run, EventBridge is looking at that and knows which lambdas to invoke depending on that schedule. Any type of external webhooks or lambda functions, they're all happening and routing through DynamoDB, which then triggers EventBridge, then triggers lambda. So it sounds like EventBridge is this choke point, but because of the way it's architected within AWS, it's actually not really a service. It's part of the AWS infrastructure. So I have less concern of it ever being a bottleneck for me. It's in some ways more related to CloudWatch as far as how it runs than something like EC2 or Lambda, which are services. EventBridge, yes, is a service, but it's part of the framework of AWS. So as all this communication is happening through AWS, I'm just capturing all of that and triggering things with it. So I really like that design. It allows for, again, just that event driven, keeps things loosely coupled, makes things very scalable. I can put CloudWatch on this and track those events as they happen. So we're going to get into more now the layered architecture and how things are organized and in horizontal layers with clear responsibilities. So once we start seeing the code, you'll see this a little more clearly, but everything is in stacks like I showed in my last video. Let's talk on separation of concerns because this is a big deal for just IT in general, right? We want this one principle of each component has one clear responsibility. So example here, file upload workflow. When I upload a file to which I'm actually doing on my computer using Mountain Duck, which interfaces with my S3 buckets. When I upload something, which looks like I'm doing it on my computer, but instead now gets uploaded directly to S3, and that triggers a notification that gets sent over to EventBridge. But all that has to happen at the infrastructure layer is this triggering of saying, hey, S3 just sent an event. Now it's the orchestrator's job to say, oh, an event came in, it looks at it, what do I do with it? Knows, okay, when an S3 object's created, I need to go invoke that Lambda. So now that we've made it through the orchestration layer, we go to the business logic layer. It knows, hey, I need to do the ingestion Lambda. I have this very simple code that says, hey, take the inventory of the files, create a new URL, and create a DynamoDB record. Then Data's job is store this data reliably so that it can be queried. I put a content ID in there, I give it a status, I store all the different files that have been uploaded into that prefix, and I assign URLs to all that. That's an example of the layers interacting with. Now for the data flow architecture, okay, so now let's talk on design principles. So I have opinions on how Lambdas should be organized. And I wanted for this architecture for them to have no trigger logic. I did not want Lambdas being triggered by anything other than Event Bridge. And that's because of that whole orchestration layer. And I wanted to be able to have all the rules kind of go through one place and kind of be able to have a control lever for everything in one place. So that said, the lambdas are still testable without Event Bridge, so I can invoke them. I typically do that from the console. I use the CLI for almost everything except this one piece, just because it's easier for me to see the CloudWatch logs and all that. So I usually invoke my lambdas right from the console. If anything happens where a trigger needs to change, I don't have to go into each lambda and dork around with that. I just again go back to my control lever, which is the orchestration layer, and make those adjustments there. And it keeps everything nice and neat because the orchestration layer decides when, the lambda decides what, and follows the how. Next design principle was this whole single source of truth. I wanted one place to go to verify certain things. So for example, in implementation here, where are the files? Everything is in S3. There's three S3 buckets, but what is in each bucket is very clear, and that is the source of truth for that state of files. And for the workflow state, that is going to be DynamoDB and a status field that I've created. That is how I know where each piece of content is in its publishing lifecycle. For YouTube URLs or any other type of metadata that's generated that ties a sort of piece of content to the outside world, YouTube being one of them, the ghost URL for the post be another, the social media posts, those URLs, all that will get fed back right into DynamoDB so that I can track it right there. And all secrets are maintained inside of Secrets Manager. So everything has a single source of. Now, this is a word that I only ever use in a presentation like this. It is definitely a $100 word that has no real conversational value, but idempotency, running an operation multiple times yields the same result. Event Bridge can retry failed invocations. Uploading multiple S3 files doesn't generate duplicate records in DynamoDB, and the system is self-correcting. So idempotency, $100 word, something that is from a design and architecture standpoint, something important to include into a design, but not something that I'd ever talk about outside of a presentation like this. So next design principle is that this is AI first. It's an AI first design. Where we stand right now is I'm very much at the MVP. Very big things that I wanted to do is to take those problems away from me that I had mentioned in my first video, which is I need all this content going out, getting uploaded to YouTube, getting sent over to my websites without me having to actually physically click buttons and do it, right? So AI first design right now is AI adapts to different concepts, types, and eventually it'll improve the model, and it's going to reduce the maintenance with fewer hard-coded rules. It's an AI first design now because LLMs are doing a lot of my work. I have automations which are not agentic, but that is my next phase. Is once all this is operating, I'll already have the tools in place, and I can use something like Bedrock agents to then take all of this and make an agentic design. So event driven, not request driven. I kind of beat that dead horse enough. So fail fast, fail visible. I want to be able to know when something fails. So all my lambdas have extensive error handling in them. They generate a lot of information to the console as they're progressing through an action. CloudWatch is involved every step of the way, so it's logging every action, and a status field shows the current state. So it does not retry forever. Everything right now is limited to 3 tries. If it can't get that done, then it stops and it notifies me that something has failed. So those are my 6 design principles. Next, for component interaction, DynamoDB is my main source of truth for all this, right? But I change something in DynamoDB, it creates a DynamoDB stream that hits Event Bridge that then triggers a Lambda. That's a lot of what's happening. Okay, so why this architecture? And what were the requirements that shaped this design? So variable content types. So I have a lot of different content that I'm intend to build, podcasts, research material, economic data. Now that's for my independent quant project. For my own personal project, and what you're watching this on is, yes, I'm sharing professional information, how to design things, how to architect things, how I do things, have people that want to learn this stuff, watch me do it. So there's a lot of different types of content there. So that helped inform. It's got to sync with external APIs. It's got to publish to multiple platforms. This is going to be a low volume. Like I said in my first video, all the content comes from right here, right? No AI slop anywhere. This is all me sharing my personal experience, my professional experience. So AI can't do that. Every idea I get, which is why you see me looking down, is me writing out notes as to what I need to talk on there. So I'm not a content making machine, right? It's very low, fairly low volume, 10 to 20 pieces of content per month. So I want to be able to control my costs. I don't need an EC2 instance running all the freaking time, even if it is a micro. Having a serverless architecture really helps in this design to keep those costs low. Requirement again was 2 environments. I've got the independent quant and I've got this site going. They have a huge overlap. This is me designing and building things, which TIQ is one of the things that I designed and built. So there's just enough difference in it that it's a different audience that's looking at both contents, but I don't want to maintain 2 separate architectures, so 2 environments. And I want this to be very flexible because I don't know where all this is going, especially this effort here, my personal site, which has my name. Really, it wraps up everything that I'm working on, which is a lot of really different things. There's going to be things on here that are things that I'm doing with my friends, colleagues, professional in nature, some things not too personal, but definitely probably not professional enough that it would qualify to be under the professional label. So because of that, I want to have this architecture be as nimble as possible. I don't like to use agile because I'm a project manager and agile means something very specific to me, but I want it to be flexible. And this layered approach allows me to create new agents and add more to this or take it away as time evolves. Cost efficiency, the beauty of a serverless architecture is it stays cheap, maintainability, for all the reasons that we just said, liability, it's all AWS driven. AWS is, not up 99.9% of the time for those of us that have seen AWS outages. But if AWS is out, then there's much bigger problems than people not getting to my website. Auditability, talked on that, flexibility. Now, the trade-offs is complexity. I do have to mention that for this. For me, it's not more complex. This is how I think. So it's very much within my line of thinking. Eventual consistency, DynamoDB streams have a delay, but that's really a non-factor for me. Nothing is happening. This is a low volume system, so nothing is happening at a scale that becomes an issue. Debugging, that has absolutely been a lot more challenging because of the way that when we started seeing my GitHub, I'm using, yes, the things are self-contained, but it's pointing to other resources. And sometimes a change in one thing causes a change in another. Thankfully, VS Code helps me with some of that, but it does make debugging a challenge. And I have experienced that. Cold start's not a factor, really. Learning curve. If I do bring people on that aren't used to this type of architecture, for them to do some work on me, for me, not on me, but for me, yeah, it can cause a problem. So ADR is not really going to get into that because it's going to get redundant with everything that I covered here. But that is the big design reasons for why I went with layered architecture and the pros and cons for all of it. So thanks so much for tuning in through all this. For our next video, We're going to get into the prompt engineering for content generation. So that's, again, one of the big reasons why this exists. So tune in for that and see how this goes. But thank you, everyone. See you at the next video.